In this video, we're going to look at how to find the derivative of other type of functions. And the first type of function we are going to learn here is the trig function. And in here, we're going to learn, of course, your favorite sine x, cosine x, etc., and other type of trig functions and how to find derivative of those. And the second part we're going to learn is how to take derivative of natural log functions. And that include function like e of x or ln of x. Surprisingly, the derivative form of these functions are quite simple and easy to take derivative with. And the third part we're going to learn is the exponential functions. And this type of function often have a format of a of x. Well, you might think we already learned this format. So we want to be careful here because this is not x to the a's power. So for x to the a's power, we can use the power rule. But for the exponential function, we'll use a different rule for this type of functions. And last but not least, we're going to learn all the combined rules. Sometimes you might be given a function that's a combination of all of these. So in that sense, you cannot use a single rule to solve it, but rather you would need to use multiple rules, such as the chain rule, the product rule, the quotient rule, all combined. And we'll do some practice on that as well. So hopefully by the end of this video, you are an expert at taking derivative. Here we have a list of the derivative of trig functions. On the left side is your trig function, and on the right side is your derivative. You might be like, this is a lot of equations. How am I supposed to remember that? Well, you can find these equations probably in the back of your book somewhere. And the good thing is, you don't have to remember all these for the most part. But out of all these equations, we do want to remember 2 or 3 of them. So let's just erase the rest that are less important and focus on the first 3. The first one is the derivative of sine x is cosine x. That one you do want to remember. And the second one is the derivative of cosine x is sine x. And you do want to remember that one as well. So they are just the opposite of each other. And one thing you want to notice is when you're taking the derivative of cosine x, you have to put a negative sign in front of it. And the third one, the tangent x, the derivative of tangent x is secant x squared. That one also comes a bit more often than the rest, so it's something good to remember. Here, let's do a practice. What is the derivative of sine x times cosine x? The derivative, let me just mark it as prime. So that will be equal to, in here, does that ring a bell? We need to use the product rule. So the trig function is often combined with other rules as well. In here, we want to use the product rule, which is if you have 2 functions, a times b, the derivative of that is going to be the derivative of a times b plus a times the derivative of b. So let's see it here. The derivative of sine x, let's write it in parentheses, times cosine x, we keep that part the same, plus sine x times the derivative of cosine x. The derivative of sine x is cosine x times cosine x plus sine x times, what's the derivative of cosine x? Sine. So that's going to give you negative sine x. Now we simplify this function, we'll get cosine x squared minus sine x squared. Now this is the answer to this question. So again, the trig function, what you really want to remember is the derivative for sine x and cosine x. They're just the opposite of each other. For cosine x, don't forget to put a minus sign in front of it. Now let's take a look at the derivative of natural log. This is one of my favorite derivative because the derivative of e to the x is also e to the x. Nothing changes. Which definitely make our life a lot easier. And the derivative of ln of x is going to be 1 over x. Also very simple. Let's look at an example. What's the derivative of e to the 5x? Well, you might say, we know the derivative of e to the x is also e to the x. So the derivative of e to the 5x is e to the 5x. And the answer is no, that is incorrect. The reason is we want to use the chain rule in this case. You have an outside function, which is e to the 5x. And you also have an inside function. So let me write that. Your outside function is e to the 5x. But you also have an inside function, which is just 5x. The chain rule states that the derivative of function is the derivative of the outside function times the derivative of inside function. So what's the derivative of outside function? It's going to be e to the 5x. And the derivative of inside function, which is 5x, the derivative of that is going to be 5. Therefore, the derivative for our function is going to be 5 times e to the 5x. Let's look at another example. Our y is equal to ln of 3x plus 5. What's the derivative of that? So what's our y prime? Our y prime is going to be, so this is, we need to use chain rule as well because we have an outside and inside function. Our outside function is ln 3x plus 5, and our inside function is this, what's inside the parentheses, the 3x plus 5. So our y is going to be the derivative of outside function times the derivative of inside function, which is going to be the derivative of ln 3x plus 5. So based on this equation, we know we just need to put whatever inside the parentheses into the denominator. So we have 1 over 3x plus 5 times the derivative of inside function. The derivative of 3x plus 5 is just 3. Okay, then we combine the result. We have 3 over 3x plus 5. And that is our answer for this question. And this is our function when we have a to the x power. So one thing we want to be careful about it is that if we have, for example, x to the 5th power, in that case, we want to use the power rule. The power rule tells us we want to bring the 5 down and times x to the 5 minus 1 power, which is 5x to the 4th power. So this is the power rule. But if we switch the location for x and 5, if we have 5 to the x power, then we need to use this equation. And our answer would be 5 to the x times ln of 5. See, this is completely different answer, and we need to use this exponential rule. What's the derivative of f prime of x? So the first part, we want to use the power rule, and that gives us 12 times x to the 4 minus 1 power, so x to the 3rd power, times the second part, we want to use the exponential rule, which is going to be 4 to the x times ln of 4. And this will be our answer to this question.